The main class serves as entry point of our Java application. The package food ordering organizes this class inside the food ordering package, which help keep our project structure clean and modular. Next, we import the login form class from the food ordering views package. This class is responsible for displaying the login window where user will choose their role, whether they are customer, a kitchen staff member, or an admin. Inside the main method, we have just one line, new login form. This line creates a new instances of the login form class when this object is created. This constructor immediately displays the login window using JavaScript. From here, the user interacts with the GUI login, and the rest of the system is launched based on the selected role. The class admin is a specialized version of user, specifically an admin user in our system. The admin class extends the user class, meaning it inherits all properties and behavior of a genetic user, such as username and role. The constructor for the admin class, it takes one parameter, the admin username. Inside the constructor, it calls super. This keyword refers to parent class, which is user. So what we're doing here is passing the username and fixed role admin to the constructor and user class. That means whenever an admin object is created, it is automatically assigned the role admin without needing to type it manually every time. This class beverage defines a beverage item. It extends the menu item base class, which means it inherits all the common behavior and data for menu items, like the name and price. The constructor takes it two parameters, the name of the beverage and its price. These values are passed directly to the menu item constructor using super, ensuring they are stored in parent class. The class customer represents a customer user in our system. The type of user who can browse the menu, place order, and check out using the app. Public class customer extend user line declares that customer is a subclass of user. That means it inherits all fields and methods from the user class, including the username and the role handling features. The constructor for the customer class, it accepts one argument, the username of the person using the system as a customer. It then calls the constructor of the parent class user using super. We pass it the username and the fixed role. String customer, this ensures every customer object is properly initialized with its identity and role in the system. This class dessert defines a dessert item. It extends the menu item base class, which means it inherits all common behavior and data for menu items like the name and price. The constructor takes into parameters the name of desserts and its price. These values are passed directly to the menu item constructor using super, ensuring they are stored in parent class.
So one of the key purpose of this class is to represent a kitchen staff member in the food ordering system. It extends the user class, inheriting all its properties and methods. One of the key features of this kitchen staff.java is the constructor takes a username from the kitchen staff as a parameter and calls the class from the user with username and the role kitchen staff. So as you can see, once the kitchen staff log in its username and select its role as a kitchen staff, it will redirect them to the list of orders in the food ordering system. So the kitchen staff.java use that we use are created when user logs in as a kitchen staff allowing them to manage order in the kitchen. So once a staff logs in its username and select kitchen staff as his role, they will have access or they can modify the orders in the food ordering system. So I think that will be all for the kitchen staff.java, since all of the properties and methods of this were inherited or extends from the user class.
This class main dish defines a main dish item. It extends the menu item base class, which means it inherits all common behavior and data for menu item, like the name and price. The constructor takes in two parameters, the name of the main dish and its price. These values are passed directly to the menu item constructor using super, ensuring they are stored in parent class.
So for the menu items, so this is an abstract base class that represents any item that can be ordered from a menu. So in the fields, we have a name and a price. So the name is protected field storing the item's name. Example, cheeseburger. And also we have a price. So it protected field storing the item's price. Examples 5.99 pesos. And for the constructor, it initializes the name and price when creating a menu item. We have by methods. So the methods is the get name. So it's simple getter to retrieve the item's name. And we have a get price. So it's simplified getter to retrieve the item's price. And also the key points is being an abstract it cannot be instantiated directly. Must be extended by concrete classes, and it provides common structures for all menu items in the system. For the order class, it represents a customer's food order in the system. So we have a static field, the ID counter. So it maintains count for auto-incrementing orders ID across all orders. And also we have instant fields. So we have order ID. So it's unique identifier for each order. And we have a customer. It represents the customers who place the order associate. And also we have items, the list of menu items in order of aggregation. The receipt order is the composition because it's tightly bound to order. And we have a date when the order was placed. And we have a completed for the ordered status flag. And for the constructor, it takes customers and items list as parameters and auto assigns ID and increments counter. And it creates defensive copy of items list and set current date and time and creates a new receipt bound to this ordered composition. And also it initializes status as a pending. And also we have a method. So we have a standard getters for all fields. We have a set completed, so it updates ordered status. We have a get total to delegate to receive for total calculations. And we have a get summary to generates formatted string with all order details. So in key points, we have a managed relationship with customers, menu items, and receipt. So it handles order life cycle and status, and it provides formatted output for order information. So for the receipt class, it handles financial aspect and receipt generation for an order. So we have a field, we have a order, so it refers to the associated ordered composition. So for the constructor, it takes an ordered object and stores the reference. So we have a method. So we have a get total amount to sums prices of all items in the order. And also we have a generate receipt text. So it creates formatted receipt using order summary. So in the key points, it tightly bound to its order. So we use compositions and relationships. So and also it handles financial calculations. It provides formatted output for receipt and reuses order summary functionality. So in user class, it's abstract base class for all users types in the systems. So the field is the username, it users logs in and the identifier, and also we have a role. So the user's role, for example, customers and admin. And also for the constructor, it initializes username and role. For the methods, we have a get username to returns the username and get role to returns the user's roles, either customers or admin. So the key points is the abstract. It must be extended by concrete user classes, and it provides common structure for all users, and also implied to be extended by customer classes used in order, and also it's simple base class that can be expanded for specific user types. So the flow of this is a user is especially a customer's place an order, and also the order contains multiple menus, and when the order is created it automatically creates a receipt. The receipt calculates the totals and can generate printable output, and the system tracks the order status and relevant informations.
The Kitchen Observer class implements the Order Observer interface to provide real-time order notifications. This component automatically triggers its an on order placed method whenever a new order is created, receiving the complete order object as a parameter, while the current implementation simply outputs order summaries to the console via getSummary. Its primary role is to facilitate communication with the kitchen panel form, where it could be enhanced to directly invoke the panel's add order to display method for seamless order updates. The observer pattern architecture enables this decoupled yet efficient notification system, allowing the kitchen interface to refresh automatically without direct dependencies on earlier creation logic. This implementation not only demonstrates the core observer pattern but also provides extensibility for production-grade features like visual alerts, kitchen display system integration, or management tool connectivity, all while maintaining clean separations of concerns. The connection between Kitchen Observer and Kitchen Panel Form forms a vital real-time bridge in the order processing workflow, ensuring kitchen staff receive immediate updates. The Kitchen Staff Observer class provides a concrete implementation of the Order Observer interface that directly bridges order notifications with the kitchen interface. Unlike the basic Kitchen Observer, which simply logs orders to console, this enhanced version maintains a reference to a specific kitchen panel form instance injected through its constructor. When the onOrderPlaced method triggers upon new order creation, it actively pushes the order to the kitchen display by calling the panel's addOrderToDisplay method rather than just logging the event. This creates a direct but properly decoupled connection between order processing and kitchen operations through the observer pattern.
The menu item class located in the food ordering models package is an abstract class that serves as the base blueprint for all types of menu items in the food ordering system. Being abstract means it cannot be instantiated directly. Instead, other classes must extend it to create specific types of menu items, such as food, drinks, or desserts. The class contains two protected fields, name and price, which represents the name of the menu item and its price in pesos. Respectively, these fields are marked as protected, allowing subclass to access and modify them directly if needed. The class provides a constructor that initializes the name and price values when a new menu item is created. It also includes two public getter methods, which is getName and getPrice, which allow external classes to retrieve the name and price of a menu item without directly accessing the fields. By using an abstract class like menu item, the application can enforce a consistent structure for all items on the menu, while still allowing flexibility for subclasses to add unique features or behaviors specific to different items types. This design promotes reusability, maintainability, and clear object-oriented structure within the system. This Java code defines an interface called Order Observer, which is part of the food ordering patterns package. An interface in Java is like a contract that other classes can follow. It contains method declarations without implementations. In this case, the order observer interface is used to apply the observer design pattern, a common software design pattern that allows objects called observers to listen or react to events happening in another object called the subject or observable. This method is meant to be called whenever a new order is placed. The order object pass as a parameter contains all the necessary details about the order. Any classes that implements this interface is expected to define what should happen when the on-order place method is triggered. For example, a class might send a confirmation email, update inventory, or notify the kitchen system. By using this interface, the system becomes more modular and flexible. Instead of hard coding responses directly into the order placement logic, the application can have multiple observers that handle different tasks independently. This makes it easier to update, maintain, and extend the system, since you can add or change observers without modifying the core order processing code. In short, the order observer helps the application react to order placement events in a clean and organized way, promoting loose coupling and better separation of concerns.
Greetings everyone, I am Sabrina Guarico and I will be discussing the Order Queue Manager.java. Today, I will be presenting the Order Queue Manager. Order Queue Manager class, which plays a crucial role in managing the order lifecycle in our food ordering system. The primary purpose of the Order Queue Manager is to handle the queue of orders placed by customers. It ensures that the orders are processed efficiently and that relevant components of the system are modified when new orders are added. So, let's take a look at the constructor getInstance method. So, this ensures that only one instance of Order Queue Manager exists throughout the application. So, the private constructor prevents external instantation while the getInstance method checks if an instance already exists. If not, it will create one. The Order Management class provides several methods of managing orders. The adding orders. This method adds a new order to the queue and immediately notifies all registered observers about this new order. The getOrders method returns the current list of orders in the queue. Another will be the completeOrder method, marks the order as completed when the dish or the orders was already done. Now, another important features of this class is its implementation of the observer pattern. The Order Queue Manager maintains a list of observers that are notified whenever a new order is placed. This is achieved through the add observer method or the order observer method, which allow other components to register themselves as observers. Next will be the notify observers method. It's right here. This method iterates through the list of observers and calls them on order placed method, which is here, ensuring that they are informed of the new order. So overall, in the summary of the Order Queue Manager class is essential for managing the orders life cycle in our food ordering system. It utilizes both the The observer design patterns to ensure efficient orders, processing, and communication between different components of the system. So, that is the content of the order queue manager.java. Thank you for your attention, and I will be discussing the admin panel form. Today, I will be presenting this class which serves as the administrative interface in our food ordering system. These panels allow administrator to view sales data and manage customer orders effectively. The primary purpose of the admin panel form is to provide a comprehensive overview of sales and order history. It enables administrator to monitor completed orders, total sales, customer order histories, and such. So, when in terms of user interface setup, the class extends JFrame, which allows us to create a window for admin panel. In the constructor, we set the title, size, and default close operation for the window. There's the set title, admin panels, dash sales overview, set size 800 and 600, set location relative to null, and set default close operation, JFrame, exit on close. Next will be the data overview. We retrieve the list of orders from the order queue manager, and this is done using the get order method, which is I explained earlier, which provide us with the current orders in the system. As you can see, the list orders is equals to order queue manager .get instance .get orders. That is the line of code responsible in getting or in calling the orders from the order queue manager to the to the admin panel form. Next will be the table setup. We created a table to display the order details, including the order ID, customer, date, total, and status. The data for the table is populated in two-dimensional array, which is filled by iterating through the list of orders. We also calculated the total sales from the completed orders during the process. There's the array, which is object data is equals to new object order size, then columns calls length. Another will be the sales overview. A key feature to this panel is to display the total sales from completed orders. We use the J label to show the total sales amount formatted to 2 decimal places. Wait, where is it? Sorry. The J label, sales label is equals to new J label. Total sales and such. You can see it in the code. Next will be the interactive features that we add in the system. The admin panel includes several interactive buttons for additional functionalities. The back button allows the admin to return to the login form. That's it. That will be the button, the explanation for the button. There will be also the most ordered items report. Button generates a report of the most frequently ordered items. When clicked, it displays a dialog with the item names and their order counts. The customer order history. This button allows the admin to view the order history for a specific customer. It prompts the admin to enter a username and displays the order history if found. Those are some of the interactive buttons that we add in the system. Next will be the layout management. The layout panel is managed using border layout. The table is added to the center while the sales label and buttons are placed in the south panel. Overall, in conclusion, the admin panel form class provides a user-friendly interface for administrator to monitor sales, manage customers' orders effectively. It also combines data retrieval, table display, and interactive features to enhance the administrative experience. That will be all for the admin panel form.
The cart form class in the food ordering views package is a Java Swing-based graphical interface that allows a customer to view and manage the contents of their shopping cart in a food ordering system. It extends JFrame, meaning it creates its own window where the customer can see the table listing all the foods items they have selected. Along with their prices, the cart data is stored as a list of menu items objects, and this list is displayed in a non-editable table using a default table model. When the form is launched, it initializes the window layout, sets the title, and fills the table using the refresh table model method, which loads all current cart items. The interface includes three main buttons, which is Remove Selected, Checkout, and Logout. The Remove Selected button lets the user delete a selected item from the cart. If no item is selected, a warning message is shown. The Checkout button finalizes the order process. It first checks if the cart is empty, and if not, it creates a new order object using the customer details and the item in the cart. This order is then added to a centralized order queue managed by the Order Queue Manager singleton. A receipt window or receipt form is also displayed, and the cart is cleared. The log out button closes the cart window and opens the login screen or login form, allowing the user to exit or switch accounts. Overall, the cart form class plays a crucial role in connecting the customer's interaction with the system to underlying business logic, providing a user-friendly to review cart items, remove if necessary, and proceed to checkout. It effectively combines UI components with back-end models to deliver a smooth cart management experience.
The kitchen panel form is a swing-based GUI component designed to display and manage food orders. It extends JFrame to create a standalone window with a fixed size of 700 by 400 pixels, centered on screen and configured to exit the application when closed. The interface features a JTable with four columns such as order ID, customer, date, and items. Using a custom default table model that prevents cell editing, columns widths are explicitly set for optimal layout. Order data is retrieved from the Order Queue Manager singleton with each other's items formatted using Java streams to display as a comma-separated list of item names and prices. The panel implements real-time updates through the observer pattern, where a kitchen staff observer notifies the form of new orders, triggering the add order to display method to append them to the table if incomplete. Two buttons provide functionality. The first one is the mark as completed. It updates the selected order status, removes it from the view, and shows a configuration dialog marked as completed, while back closes the window and returns to the login screen. There's also an error handling that includes validation for order selection before completion.
The login form class is a graphical user interface for this food ordering system designed to authenticate users and direct them to the appropriate dashboard based on their role. The class extends JFrame, making it a standalone window. The constructor initializes the window with the title, size, and layout, ensuring it closes properly when exited. A JPanel with a grid layout organizes the input fields, such as JText field for the username and a JCombo box for selecting a role, which is the customer, kitchen staff, or admin roles. A login button triggers an action listeners when clicked. Upon clicking the button, the system retrieves the entered username and selected role. If the username is empty, an error message prompts the user to enter 1. Otherwise, a user object is created based on the role, instantiating customer, kitchen staff, or admin classes. The login window then hides itself and opens the corresponding dashboard menu for customers, kitchen panel form for kitchen staff, or admin panel form for administration. This Java code defines the menu form displayed as a JFrame. The class starts by importing necessary packages including models, the customer, and menu item. The menu item factory for creating menu items and swing components for building the UI. The menu form constructor takes a customer object, setting the window title to greet the user, configuring the frame size, and centering it on the screen. The interface uses a JTab pane to organize menu items into 3 categories, which is the main dish, beverage, and dessert, each dynamically generated via the build category panel method. This method creates a panel for buttons for each menu item, where clicking a button adds the item to the cart using menu item factory and displays a confirmation message. A view cart button at the bottom opens a cart form to review selected items. So the importance of this class lies in its role as a primary interaction point for users to browse and select food items, leveraging the factory pattern for consistent item creation and maintaining a cart list for order processing. Without this form, users wouldn't be able to navigate the menu or build their orders, making it essential for the system's core functionality. This code defines a receipt form class in the food ordering.views package. The class imports order from food ordering.models to access order details and using swing components such as JFrame, JText area, JScroll pane, and JButton to build the user interface. A non-editable JText area displays the receipt text generated by order.getReceipt and generate receipt text using a monospace font for alignment clarity. A scroll pane wraps the text area for long receipt, and an OK button disposes the receipt and returns to the login form when clicked. The layout uses border layout, placing the scroll pane centrally and the button at the bottom. This form is crucial for providing customers with the transaction summary, ensuring transparency, and confirming order details, enhancing user trust and experience in the system.